Hey y'all, it's Miss G here, and we are going to talk about 2.3. We're continuing on with your Chapter 2 notes, and today we're going to be talking about solving inequalities using multiplication or division. So back in section 2.2, we were talking about using addition or subtraction to solve inequalities, and all the steps were the same as whenever we were solving equations. So we have two different cases here that we're going to talk about when we talk about using multiplication or division to be able to solve. And there is a nuance here with case 2 that we want to make sure we pay close attention to and is really going to be the focus here of 2.3. Okay, so case 1. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So an example of this would be, let's say we have 5x is greater than 25. All right, so in order to solve this inequality, we want to isolate the variable, and right now 5 is being multiplied by x. So I would do the opposite, and I would divide by 5, and that would give me x is greater than 5. So when we talk about case 1, about when you multiply or divide, we're talking about this step right here. This was dividing, okay, by a positive number. So even though we don't write the positives, okay, on our numbers, we only write the negatives, this is a positive 5. So this is what they mean. If you divide by a positive number, then the inequality remains true just the way that it is. Okay, there's nothing that we have to do to the inequality sign. So let's say we had 2/3 x is less than or equal to 8. All right, so in order to solve this, we would multiply by the reciprocal because we have a fractional coefficient. So we would multiply by 3/2. We would multiply the other side by 3/2, and that would give us, I'm going to write over here, x is less than or equal to, okay, these 3's cancel, these 2's cancel, right, and we're left with the x, less than or equal to 8 times 3 is 24, okay, 2 times 1 is 2, so 24 divided by 2 gives me 12. All right, and so when we talk about the multiply by a positive number, we're talking about we multiplied, okay, we multiplied by a positive 3/2. Okay, so that's what we're talking about. What did we do to the inequality to solve? Okay, it has nothing to do with how the inequality started out, whether they're positive or negative numbers. Okay, it's about the action that we take to solve. Okay, so now let's move on to case 2, and this is where the nuance is, and I imagine a lot of y'all have already heard about it from last year's math class, but when you multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be flipped for the inequality to remain true. Now, we haven't been talking about it up here, but remember, we can always plug numbers in to check our answers, right? If we were to take a number, let's say that we took let's take 2, okay? Let's go back to this example right here, okay? 5x is greater than 25, and we simplified it, or I'm sorry, we solved it to be x is greater than 5, right? So I should be able to plug a number into x in both spots, and they should either both be true or they should both be not true, okay? That means that I did it correctly, right? So let's say I take x is 2, and I say, is 2 a solution, right? Well, if I plug in 2 here, 5 times 2 is 10. Is 10 greater than 25? No, right? So if I plug in 2 over here, is 2 greater than 5? No, but do you see how the no is the same? Okay, that means that these inequalities stayed true because they gave us the same result when we plugged a number in for x, okay? So the reason that we have to do this whole flip of the sign is so that we can keep the inequality to remain true. So let's say I had negative 4x is greater than 12, okay? So for us to solve, we're going to do the inverse operation. So negative 4 times x means we're going to divide by a negative 4. We're going to do the same thing to the other side of the inequality. These negative 4's cancel out, right? So because I divided by a negative, right? I chose to divide by a negative. A negative was already here, and that doesn't matter. What matters is what I chose to do. So I have x's, and now I must flip this sign from greater than to less than, and then I just continue to do the math. A positive divided by a negative is a negative number. 12 divided by 4 gives me 3, so I know it has to be a negative 3, okay? So we should be able to check similar here, right, to see why it has to be true. So we had the inequality, negative 4x is greater than 12, and we have x is less than negative 3. So we had to flip this sign so that we could keep these inequalities to be true, okay? So let's pick a number to plug in and see if we get the same result, okay? So I'm going to plug in, I'm going to say is x equals negative 4 a solution to this inequality? Okay, if it ends up being a solution here, it needs to be a solution over here as well. So if I plug in negative 4 here, that's negative 4 times negative 4 is greater than 12. Negative times negative is a positive, which gives me a positive 16. 16 is greater than 12, so I would say, yes, that is true. Okay, so let's go ahead and plug this negative 4 in. So negative 4 is less than negative 3. And that is also true because it is smaller, okay? Negative 4 is further away from 0. So if I had not flipped this sign and it had been like this, and I had plugged in the negative 4, then that wouldn't have been true. So the reason that we end up having to flip it is so that the answer will stay the same when we plug in solutions. Okay, last little thought, which we'll talk about in class. Don't worry, we're not only using a video to discuss 2.3. But whenever we are on a number line, okay, and let's say I have it like this. If we were to start at 0 and we were to do addition or subtraction, right, we're just kind of walking along the number line, right? We're walking up and down the number line. It doesn't matter where we are on the number line. We're just kind of walking from our starting point and walking back. When we multiply or divide by a positive number, we kind of just leap, right? We just kind of leap by grouping, almost like skip counting, right? If you multiplied multiples of 2, 2, 4, 6, 8, so we just kind of hop along, right? Okay. Whenever we multiply by a negative number, example, let's multiply 2 by negative 1. We don't just move 1 over, or we don't just leap a negative 2. We actually flip all the way over to the other side of the number line, because 2 times negative 1 is negative 2. So we actually flip over, which is why when we multiply or divide by a negative, we must flip the sign because now we're facing the other way. Okay, so a little bit of background for you in terms of why that rule is in place. Okay. So finishing out your notes, these properties are true for all of the inequality symbols, okay? So whether you're doing less than, greater than, less than or equal to, or greater than or equal to. So let's do a couple of these practice questions where it wants us to solve and then it also wants to graph the solution on a number line. So here we have x divided by 5 is less than or equal to negative 3. So I want to get this x all by itself, so I'm going to do the inverse operation and I'm going to multiply by 5. When I multiply by 5 on one side, I have to do the same thing to the other. 5 divided by 5 cancels to 1, so it leaves me with x. Because I multiplied by a positive number, I'm just going to keep the sign just the way that it is, and I'm going to have x is less than or equal to negative 15, because negative 3 times 5 is negative 15. All right? So on a number line, not the straightest line ever, I'm going to put this number right here in the middle. Okay? Then I'm going to go ahead and put my plus 1 this way and my minus 1 this way. Remember, on the negatives, you got to kind of pay attention so we get it right. I'm going to have a closed circle because it says or equal to, and then it says x is less than or equal to. See how it has the small piece here? It's also facing, going the left direction, and with the variable on the left-hand side, it's going to follow the direction, right, of the inequality. So I know that it's going to the left because the less than is always to the left, okay? So here we didn't have to do anything different. It was just like as if we were solving an equation, and yeah, nothing different there because we multiplied by a positive number. So over here, we are going to end up dividing by 6 to be able to solve this inequality. So we have 6x less than or equal to negative 18. I'm going to undo this multiplication that's happening between 6 and x by dividing, okay? I have x is less than or equal to negative 18 divided by 6 is a negative 3, okay? Again, I divided by a positive number, which means I didn't have to do anything special, and I just solved kind of like what I would call normal, okay? So then it also asked me to graph on a number line. So I'm going to go ahead and put negative 3 right here. I'm going to add 1 to it, gives me a negative 2, and I'm going to take away 1 to go to the left, which gives me negative 4. I see that it has an or equal to, so I know that I'm going to have a filled in circle because it includes negative 3 as a solution. And then it says less than or equal to, so I'm going to be going here less than to the left. All right? So these top two examples that we have, nothing new, right? Very, very similar to when we were just doing it with equations. So now we have these next two examples, okay? And now we're going to work on the case 2, okay? So if we were to put in your notes, remember we had case 1 and case 2. So these ones right here are case 1, okay? And then this next row that we're going to do is this case 2, where we're going to have to pay attention because we're going to be multiplying or dividing by a negative. So I'm going to come over here just so I have a little bit more space to write. Okay, so here it is. It says negative 3/2 n is less than or equal to 6. So I want to get this n all by itself, so I'm going to multiply by the reciprocal because that's how I get rid of fractional coefficients. So I would multiply by negative 2/3, which means I have to do the same thing on the other side. Okay, so immediately when I write down this multiplied by a negative, I already know flip. Do you notice how I haven't even done the rest of the math? I wrote down multiplying by a negative, so I flipped my sign, so I didn't even have to think about it, okay? When I multiply by the reciprocal, that cancels this out and just leaves me with n, okay? And then over here, I just continue to do my math. 6 times negative 2 is 12. Negative 12 divided by 3 gives me a negative 4, all right? And so this right here is my inequality. I need to graph it on a number line. Okay, so I'm going to say negative 4, negative 3, negative 5. I see that it has an or equals to, so I'm going to make sure it's a filled in circle. And then it says n is greater than, okay, or equal to. So greater than always goes to the right. You could also look at it as the alligator mouth is facing the variable, so the variable is bigger because it's being eaten by the alligator mouth. Okay, you could also plug in a number, so I could take this negative 3 and I could plug it in for n to say negative 3 is greater than or equal to negative 4, and that is a true statement, so I know that I've taken my line the correct direction. Okay, so remember, you know how inequalities make sense in your brain. I'm just saying all the different pieces that might work for different people, okay? So last one, we have negative 2y greater than negative 0.8. So this is being multiplied by negative 2, so I'm going to divide by negative 2, all right? So immediately, because I divided by a negative 2, I already know that I'm going to flip this sign from greater than to less than, okay? So I'm just going to get that flip over with. So then I can just continue on with the math. So negative 2 divided by negative 2 is 1, which cancels out so that I can just have the variable by itself. Negative 0.8 divided by negative 2. A negative divided by a negative is a positive, so this is going to be 0.4. So y is less than 0.4. If I were to put it on a number line, I don't have to stress that it is a decimal. I get to choose the increments on my hash mark. So I'm just going to go up by tenths, okay, because it's very easy that way. I'm going to have an open circle because there's no or equal to. And then I see y is less than 0.4. It's also facing, the arrow would face the left, right? When the variable's on the left-hand side, it follows that rule. Okay, whichever way you like to think about it. And here would be the graph for that. Okay, so the biggest thing here is that you see that we flipped, right? Here we flipped. And that is all because we multiplied by a negative or we divided by a negative, okay? And so that's what we have to pay attention to. We can't get so caught up into solving inequalities that we forget to do the flip of the sign, okay? You're going to kind of figure out the order in which how you do things to make sure that you keep everything in line, all right? So let's finish up with a word problem here, okay? So it says a submersible wow, let me start again. A submersible descends 37.5 meters per minute from sea level to explore a shipwreck. The shipwreck is deeper than the Titanic, which is at an elevation of negative 3,810 meters. How long does it take the submersible to reach the shipwreck? Okay, I'm going to go ahead and start trying to pull some of the math out of the problem. So descends negative 37.5. So I'm going to write that down. I've got a negative 37.5, okay, because descends means down, right, negative, from sea level, okay? And so I'm actually going to draw myself a picture because sometimes pictures even work better. So that's at 0. That's what sea level is, right? Okay, and then it says the shipwreck is deeper than the Titanic, and the Titanic, okay, let's say the Titanic is here, is at negative 3810. So we're coming down, right? We're going down into the ocean, yes? And it's saying that the shipwreck is actually beyond that, okay? And that's where the shipwreck is, okay? So we've already gone down in elevation, 3,810, but it's going to go even further, okay? So it asks, how long does it take the submersible to reach the shipwreck? So here I said it descends at 37.5 meters per minute, okay? So when we see the word per, we need to think multiply, and this is usually where the variable is, okay? So I'm going to go ahead and define x equals minutes because that's what we're trying to figure out, right? We want to know how long it takes. So negative 37.5 times x, okay? That's going to give me the distance, right, of how I can get to my shipwreck, okay? So I know that negative 3,810 meters is going to be on the other side of this inequality. And now it's time for me to figure out, do I put a less than or equal to or a greater than or equal to? Okay, so what do you think? All right, what do you think? So based on this picture, let's say this is going to be a negative just to give us like a visual, even though this isn't the answer. This is going to be negative like 4,000, for example, right? That I'm not saying that's the answer, right? But let's say if it's going to get deeper, this number is actually going to be further away from 0, which means it's getting more negative. And if it's getting more negative, that means that this has to be less than or equal to negative 3810, okay? So we have to pay attention to the signs, right? Because signs are really, really important when it comes to numbers. So now that I have my inequality written, now I can solve it, okay? So when I divide by negative 37.5, because this is being multiplied by x, right? So I'm going to cancel that out. I'm going to divide by negative 37.5. I see that I divided by a negative, so I immediately have to flip this sign, okay? Because I'm divided by a negative. This cancels out to give me x is greater than or equal to, let's see, 101.6 minutes, okay? So let's gut check this, okay? It says greater than or equal to, so time. I'm in my little submersible, right? My little ship. And I'm just coming down, 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 down. I'm taking time, 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 time. So if I get to here where the Titanic is, that would be at 101.6 minutes, right? So if I wanted to get past the Titanic, it makes sense that it's going to take me longer or greater than 106 minutes to keep going to get to wherever the shipwreck is. So this makes sense, which also validates the way that we set it up, okay? So hopefully that makes sense, guys. Of course, we're going to talk more about 2.3, but this is going to help you get started with your practice problems. Make sure you keep your notes filled out and bring your questions to class.